5 on the area of a triangle. We probably recall the generic formula for the area of a triangle, where area is equal to 1/2 times the base times the height. Now, because the height may not be one of the edges of the triangle, it could be an internal side, or it might be something that you drop down and then find the height. We don't always know the height. If we don't know the height, but instead know information about the angles or the side lengths, then we can use some substitution and find that, because don't forget, that h right here is what we used to define the law of sines. And so instead, remember that if I talk about angle A, for example, we remember that sine of A was equal to actually, with the way this height is defined, I want to do C. Sine of C is equal to the opposite over little a, so that would be h over a. And then I can also talk about, I guess I could have done a, so I was just looking at this side first, but little a now. So big A, sine of big A is h over little c, and then if I can solve for h on both of these, remember that a times sine c was equal to h, or c times sine a was equal to h. And so if you just replace h, like in one of these, we have our in the case of this triangle, this side down here is b, the base. So if I replace h with one of these two things, let's say I replace it with doesn't matter, c sine a, then I can see that my formula turns into area equals 1/2 times b times c sine a. And so that's this formula right here for, I don't know why they call it area K. So let's just make, well, actually I do know why, because capital A is an angle now. So this is the A for area, not the A for the angle. I guess they're calling it K for area. Too many A's. But there we go. So that's where this formula comes from, and I can actually do it in terms of any of the angles, of course, where depending on where I drop my height and what my base might be. Okay, so it's 1/2 the product of the lengths of two sides and the sine of the included angle. So the angle that we use has to be the angle between the two. So between C and B, or if I drop a height down in a different way, I could use AB sine C, where C is the angle. Does not correspond with A or B. Okay, let's take a look at this example. We've got an irregularly shaped lot here. It's an odd pointed shape that is roughly and conveniently triangular. Two of the three sides measure 246 feet and 208 feet, coming together at an angle between them of 135 degrees. So what is the piece of the property? How big is it in square feet? So they've given us the angle between them, so I can get the area using this formula without even having to draw my picture, but I can if it helps. But we have 1/2 times the two sides and the angle between them's sine. So 1/2 of 246 times 208 times the sine of 135 degrees. I didn't need to use law of sines first to find one of the things, because I already had, if I draw real quick, I already had, let's label these sides, 246, 208, and I already had a measure between them of 135. So I don't need to find h. I know that I can use the law of sines to find the hypotenuse if necessary. So I don't need to solve the triangle, find the other angles. I just use the formula, got the area. So the area is, find my calculator. Come on, calculator. 1/2 times 248 times 208 times, I gotta change this calculator into degrees, the sine of 135 in degrees. So the area is 18,090.62 square feet.